And there it is. Now, let's look at a couple of applications. And now we're going to solve problems identical to 4.2 but backwards. Here it says compounded interest, 73.74. $3,000 is invested. That's A. I'm sorry, that's P. I gotta really get those down. And it invests in an account at an interest rate compounded continuously. That means A equal e to the RT. Find the time required for the amount to double if the interest rate is 0.055. Well, let's do part A. Part A, double. I'm going to start with 1,000 e to the 0.05t. And in part A, I want the 1,000 to become 2,000. Okay, no need to squish it. I have all the space in the world. Well, this is an exponential function. The way I solve exponential or log, I isolate the name by itself, so I divide by 1,000 before I begin. 2 equal e to the 0.055t. I'm going to take the natural log of both sides. Those undo each other. Natural log of 2 equals 0.055t. And if I divide by 0.055, plug this in my calculator, that's how many years it'll take. And luckily I have a calculator and I know how to use it. I'm going to take natural log of 2. This calculator has its own. There. Divided by 0.055. 12.6 years. It's going to take 12.6 years to get your 1,000 to become 2,000. The 1 million to become 2 million. The 1 billion to become 2 billion. Whatever it is. How about part B? Part B is asking, how about to triple? Well, I want to take $1,000, put in an account accumulating interest continuously. I want to know how long does it take until the 1,000 triple becomes 3,000. Again, an exponential equation, isolate the name by itself, which is, that's how we solve any math equation. You isolate the name by itself. Since I have an exponential, I'm going to log both sides, and no big secret, we're going to use base E, 0.055t equal natural log of 3, divide by 0.055, and t will be how many years? I'll go to my calculator. All what I have to do is go back and replace that by 19.97 years. 19.97 years. 2 decimals will do the trick. I have 2 more examples to go. I made a problem like 75 because there's nothing like it, and I want to make sure that you see it. It's an important application. And this is what it says. It says a deposit of $300. P is $300. Is made into account that earned interest at a rate of 4%. Very good. That's fixed. How long? You're looking for time. How long would it take for the balance to triple when the interest rate is compounded? And let's do this. So we want the balance to triple. We want A to B. You put in 300. 3 times that is 900. In part A, the interest is compounded annually. Well, let's see. Annually, for those 3, we use A equal P into 1 plus R over N raised to the NT. So for A, B, and C, and we know what A is. A is the amount that we desire is 900. And this is how we figure out investments, retirement, all of these things. 1 plus R. In this case, R we know. R is 0.04. The only thing that's going to change between those problems is yearly, monthly, daily. So yearly, I put a 1 in there, raised to the nt, raised to the 1 times mt is what I'm looking for. This is an exponential equation. I isolate the exponential by itself, so I divide by 300. I'll get 3 to equal 1.04, in this case raised to the t. I would log both sides, no big secret. We're going to use ln. Properties of logs, this moves up front. Natural log of 3 equal t times natural log of 1.04. And if I divide by natural log of 1.04 both sides, I'll get t to equal how many years it'll take. I get my calculator out, and if I take natural log of 3 divided by natural log of 1.04, it's going to take 28.01 years. 28.01 years, roughly. Got part A. If I want to tackle part B says monthly. Well, the only thing that's going to change in B, 900 is going to equal 300, 1 plus 0.04. The only thing that's going to change when you say monthly, how many months are there in a year? There are 12 months in the year, raised to the 12t, and the work is the same. Isolate, literally as we did, 3 is going to equal, and if I take my calculator, oh, wrong calculator, sorry. If I take my calculator, and now I'm going to take 1 plus 0.04 divided by 12. That's 1.003. And the work is identical. It's not going to change. So what we do, I don't know why I squished them. We're going to take natural log of both sides, and we're going to get natural log of 3 equal 12t times natural log of 1.003. If we divide by 12 natural log of 1.003, there it is. I'll get t to equal, and now it's a matter of plugging this in your calculator. In my calculator, if I take ln of 3 divided by parentheses 12 times natural log of 1.003, 30.56 years. 30.56 years. Let me just check really quick. And here I want to speak to the importance of rounding. The part I didn't mention. You notice, you will go, wait a minute, how can it be more years? It doesn't make sense because of this rounding. When I take 1 plus 0.04 over 12 and I plug that in my calculator, that's really 1.00333333, and it continues. It's 1.003. That's what the calculator told me. If I take 1 plus 0.04 divided by 12, that's what the calculator is saying. It's saying this is 1.033333. If you really don't want to, I'd rather you use the answer. If you don't want to use the answer, make sure you take enough decimals. That is, if I was working this, I will say, you know what? Put the answer there. And let's see what happens. If I use answer, watch what happens. If I was to take now, the answer stored in there. If I take the last step right there, natural log of 3. So if I take natural log of 3 divided by parentheses 12 times the natural log of answer. 27.51 years. 27.51 years. That's the actual answer. And if you decided, you know what, I don't want to do this. If you decided, but wait a minute, if I take this value, and let's say I'm going to take 1.00 and I'm going to take 5 decimals, you could do that. You could say, look, I'm going to take natural log of 3 again, divided by parentheses 12 times natural log 1.00. Let's go 4 threes. The answer is much, much, much better. So, whenever you want to round, make sure you figure out how your calculators work. I suggest you stick with answer, you're safe. You want to round, make sure you take enough answers. I'm going to do part D. Part D says the same deal except we're using continuous. What's the difference between compounded n times 3 and continuous? It's still 900, it's still 300, but it's e to the 0.04t. Isolate the trig function by itself. 3 equal e to the 0.04t. We're going to take log both sides, always natural log of 3. Here, the beauty of this, these cancel out, and I really saved myself some work. And t will equal, and now I'll simply go to my calculator, say let's take natural log of 3 divided by 0.04. And it's going to take 27.47 years. 27.47 years. And there it is. One more problem to go. And I'm going to do certain parts of this problem just to make sure we're solid on this. Here, complete the table below. The time t necessary for p dollars to triple. Again, triple. You put in p amount you want to triple. Interstate compounded continuously. Let's pick a couple of those. So if they don't give us an initial value, we pick a value. Let's say $100. Then A, triple. Anytime they don't give you an initial value, you could choose 100. Isn't that $300? So just for practice, in the first part, if R equal 0.02, 300 equal 100 e to the 0.02t, because this is compounded continuously. And for practice, isolate the trig function by itself. I'm sorry, did I say trig? I'm so stuck on trigonometry. I meant the exponential. 3 equal e to the 0.02t. And now what? Natural log both sides. Natural log of 3 equal 0.02t. Divide by 0.02t, and there it is. Oops. Divide by 0.02. I'm getting carried away. You know how that is, right? When you're doing something you enjoy. If I take natural... Hey, wait, we just did that. Divided by 0.02. 54.94 years. 54.99 what? 3 years. That's how long it takes. And this is a good practice, nothing more. What if I pick 6%? Now, what if I pick 8%? R equals 0.08. Well, what's going to change? 300 is going to equal 100 e to the 0.08t. If they increase from 2% to 8%, isolate the trig function by itself. Did I say trig again? You guys, I'm so sorry. 3 equal e to the 0.0. I meant log function. Log both sides. Ln of 3 equal 0.08t. Divide by 0.08. Make that nicer. And t will equal, again, my calculator. If I take ln of 3, I already have it, divided by 0.08. Hopefully you're seeing a pattern. Look at that. 13.73 years. And I'm going to do one more. What if I was able somehow to get, it's very hard to do, what if I was able to get 14%? Well, guess what? 300 will equal 100 e to the 0.14. 1 for t. Isolate the exponential function by itself. Log both sides. Not 1.4%, 14%. Divide by 0.14. And t would be, again, my calculator. All what I have to do is go back. I could restart the whole thing. That's not that much of a work. Divided by 0.14. And that turns out 7.85 years. 7.85 years. And there's your homework.